थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। Join Infinity Learn today.
Hello, good noon, my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. आज हम चर्चा करने वाले हैं the mole concept application of the stoichiometry, empirical formula and molecular formula. So the ratio journey, that is empirical formula. From the percentages we are going to see it. Dear children, I just want to tell you, those students who are preparing for NEET examination, this session is going to be super awesome and it is super important, and I strongly recommend those students who are already dropped from NEET 2025 to 2026, we strongly recommend you to join these sessions, and please like and share and subscribe to Infinity Land YouTube channel. Good afternoon, Anisha. Hi, good afternoon, Anisha. Can you all able to hear me? Just confirm in the chat box. Yes, no, yes, a thumbs up and fire emoji so that we can start. So those students who did well in the NEET examination 2025, well and good. And if anything not expected went good for the 2025, you can take a drop for 2026 and you can see the program Atreya. So Anisha, look at here, all students, my dear children, if you want to drop for the NEET examination and wanted to prepare for 2026, it is on us. And we want to change your status from I didn't to, and I want you to make you, I did it, okay, and I will do it. Dandrash, sir, will these lectures will be enough for NEET 2026? Of course it is. And we are giving the content and we are giving the explanation, we are giving the questions at the level of NEET examinations. So undoubtedly these are very, very important. So crack your NEET examination introducing Atreya, India's most powerful NEET repeaters program. It's a wonderful program which includes P² CB. What is Danu? Hi, good afternoon. What is P² CB program? In general, those students preparing for NEET examination, physics is going to be a nightmare. Yes or no? Yes, I strongly believe it. And the example is NEET 2025. Physics is slapped like anything. Yeah, a tappad mara hai na. Okay, anyways, we want to come up out. So, a resolution for that universal program. Yes, Danum. So P² CB, physics twice a day and chemistry and biology along with it. And link is there in the description box and pinned messages, and just click it and you can explore the program. This Atreya program is a revolutionary NEET preparation with P² CB program, double focus on physics with chemistry and biology. It's an excellent program. Enroll now and you can click it and you can see, and course description, batch commencement just started on May 23, my dear children, and the classes are going to be Monday to Saturday and Sunday. आपके लिए छुट्टी है, थोड़ा relax करने के लिए. And duration of each class is going to be 90 minutes का है. हर दिन 3 classes होगा, 2 concept उसमें एक practice session है. And there are 18 classes per week and double physics practice sessions be here. And this much efficient program not given by anybody except Infinity Learn by Sri Chaitanya Academy. Yes, batch is in English, Hindi bhi hai, English bhi hai, okay, pure English and Hindi and English combination bhi hai. And interactive classes by expert faculty, 465 classes are there, and there are 240 DPPs. बच्चों, dedicated practice sessions, 120 plus hours practice sessions with expert faculty. It's not a simple thing. And after each and every session notes भी आपको दिया जाएगा. And batch size काफ़ी important है. And for the practice session का 20 to 25 students will be there, ताकि आपका थोड़ा मौका मिलेगा एक्सपर्ट फैकल्टी से बातचीत करने का. सो कस्टमाइज्ड डाउट क्लैरिफिकेशन विल बी देयर. ओके, नो प्रॉब्लम दानो. प्योर इंग्लिश क्लासेस विल बी देयर. ओके, and 20 to 25 batch size is super important. And if this batch number is very less, you will be having an interaction with your faculty, and you will be having a customized interaction so that a pinpointed doubts also will be clarified here. Danu Chopra, okay, Danu, fine. And coverage of total 11th and 12th. Total 11th and 12th will be there, and description box, the link is available, and you all click it and you can do it. And coming to those who already did NEET examination, link is available and description box. Rank and college predictor, this option is there, and you can click and you can find your dream medical college by entering your score and your details. And without delay, I just want to take you into the empirical formula and molecular formula. Okay, dear children, we discussed mole concept. After this mole concept, we need to enter into empirical and molecular formula, right? Yeah, percentage composition. So experiment is available. If a compound is newly discovered, by taking the experiment, we are going to check how much percentage of the particular element is there. So from the percentage of particular element, you have to take the ratio of these, and the ratios are nothing but your empirical formula. So the percentage composition, from there we have to, discuss about empirical formula and molecular formula and vapor density calculations, and eventually we go into the stoichiometry calculations. This is very, very important. The composition of pure chemical compound is always fixed according to law of definite proportion, Proust. And the weight in grams of an element present in 100 grams of compound is called as percentage of that element. That can be calculated by taking the mass percentage of the particular element is equal to mass of that element in the given molecular mass upon given molecular mass into 100. So this is very important formula. Based on that, fundamental level questions will be there. And how do we get mass percentage of element? That is very important. Mass percentage of element can be calculated by using various experimental methods. So let us say the element here, carbon. How much carbon is present in that given compound is assessed by using a method called Liebig method. Let us not discuss about Liebig method right now. And by taking the compound and do this Liebig experiment, so the carbon present in that compound is converted into carbon dioxide. So the substance measured is going to be the mass of carbon dioxide. And taking the mass of carbon dioxide, you can calculate the percentage. Percentage of carbon is going to be mass of carbon dioxide upon molecular mass of the compound into 12 by 44 into 100. So why it is 44? Because molecular mass of carbon dioxide is going to be 44. Got it? Similarly, hydrogen is the element. You can calculate the percentage of hydrogen by using a method in the same experiment is called Liebig's method. In this Liebig's method, you have to convert the hydrogen into the water vapor. Hydrogen into water vapor. So you have to calculate the weight of water. And that is percentage of hydrogen is equal to weight of water upon weight of the compound into 2 by 18. 18 is the molecular mass of the water into 100. So this is the formula that can give you the percentage of hydrogen beta. So you can also calculate the nitrogen. Nitrogen can be calculated by using two methods. One is Dumas method, another one is Zeldal method. In Dumas method, the nitrogen present in the compound is converted into the nitrogen gas. So this nitrogen gas is estimated number of milliliters of nitrogen gas. Volume of nitrogen gas is estimated. My dear children, in the NEET examination you have practical chemistry. In that practical organic chemistry, this formula also again you reuse it. So this is very important. So the percentage of nitrogen is equal to volume of nitrogen upon the mass of the compound into 28/22400 into 100. So why 22400? So this is taken in the milliliters. So molar volume of the 1 mole of the gas is going to be 22400 milliliters. So based on that you can calculate the percentage of nitrogen. Hope you are understanding all clear. A thumbs up and fire emoji. So Danu, yes. So let us talk about nitrogen is also measured by using this Zeldal method. Anisha, the other method ammonia is used, the molecular formula is going to be 7. That is Anisha, that is Zeldal method. That is Zeldal method. In that Zeldal method, as Anisha is saying, it is going to be weight of ammonia is taken into the consideration. Weight of ammonia is going to be consideration, and this preparation is very important and it is sufficient for your NEET examination. And this NEET YT channel, YouTube channel from the Infinity Line, it is purely free of cost. We need not have to pay anything, just little bit promotions will be there. Okay, so nothing more than that. Take a pen and paper and solve along with us and learn along with us. Okay, so this much content we want to give you in seamless way. So the percentage of nitrogen is equal to weight of ammonia upon weight of compound into 14/17 into 100. Why 17? This is the molecular mass of the ammonia. What Anisa said is correct. What Anisa said is correct. Okay. Now similarly you can calculate sulfur. Anisha and Danu Chapala, can you all tell me the sulfur is estimated by which method? Method name is also important. It is there in the NCERT. It is there in the NCERT. Tell me the name. I want to see in the chat box. Quickly. This is already discussed. I want to just recap for you once. Anisha, you tell me what is the name of the process for detection, estimation of sulfur. Jaldi, jaldi. I want you to tell, come on. So that is done by using Carius method. So in the long tube, so the organic compound is taken and it is treated with barium chloride, so that barium sulfate precipitate is going to be formed. So the weight of barium sulfate is taken. So the percentage of sulfur is equal to weight of barium sulfate upon weight of compound into 32/233 into 100. Why 233? So 233 is the molecular weight of barium sulfate. Here 17 is the molecular weight of ammonia. 22400 is molar volume, and 18 is the molecular weight of water, and 44 is the molecular weight of carbon dioxide. Hope you understand. Halogens also done by this method. In the next slide I want to show you. Anisha, next slide I want to show you. Any doubt you can just discuss with us. Dear children, any doubt? Okay, take a picture, screenshot everybody. This formula is going to be super important for you all. Taken? Now, Now here we are going to see the chlorine, bromine, iodine and phosphorus. These are all done by using Carius method, and the compound is treated with silver nitrate, so that if chlorine is present, you are going to get silver chloride. If bromine is present, you are going to get silver bromide and silver iodide. Okay. And if it is with magnesium pyrophosphate is going to form Mg2P2O7, magnesium pyrophosphate. Okay, this compound is treated with magnesium mixture. Okay, let us start with the Carius method. Chlorine, so the weight of chlorine is formed, so the weight of chlorine is assessed, so percentage of chlorine is equal to weight of chlorine upon weight of compound into 35.5 into 143.5 upon 143.5 into 100. Why 143.5? It is going to be the molecular weight of silver chloride. Similarly, silver bromide mass is assessed. So the percentage of bromine is equal to weight of bromine upon weight of compound into 80 by 188. 188 is the molecular weight of silver bromide. Okay. And why 35.5? Atomic weight of chlorine is 35.5. Silver bromine is going to be 80. Iodine is going to be 127. And here going to percentage of iodine is equal to weight of silver iodide into 127 into 100 by weight of a compound upon molecular weight of silver iodide. Molecular weight of silver iodide. And the compound is taken in the Carius tube and mixed with magnesium mixture, and it is heated strongly so that phosphorus present in this compound is converted into magnesium pyrophosphate, and the weight of magnesium pyrophosphate is calculated experimentally, and the percentage of phosphorus is going to be weight of magnesium pyrophosphate into 62 into 100 by W, weight of the compound into 222. 222 is the molecular weight of magnesium pyrophosphate. Mg2P2O7. And what is this? Oxygen. So to measure the amount of oxygen, there is no special method. Rather, we have the method like a subtraction principle, and the subtraction principle gives you the percentage of oxygen is equal to 100 minus the sum of percentage of all the elements, like percentage of carbon, percentage of hydrogen, and blah blah blah. It goes on like that. So once we get the percentage of the carbon, hydrogen, nitrogen and sulfur, then chlorine, bromine, iodine and phosphorus and oxygen, you can calculate the empirical formula and you can calculate the molecular formula further. So take a screenshot of this, everybody click. Taken. Exactly. Now weight percentage of oxygen in sodium hydroxide. Simple. Percentage of oxygen is equal to, so one oxygen atom is there, 16 upon the molecular mass of sodium hydroxide is 40 into 100. Got it? So that is going to be your answer, is going to be 40%. Got it? Clear better? Fine. So this is the simplest question, the formula, molecular formula and the empirical formula. And we are coming to the main course of the day. Formula that represents the chemical composition of the substance. That is simplest formula. There are three kinds of formulas that you know. So what is this three kinds of formula? Can you, somebody, Anisha, somebody tell me, there are three kinds of formula that we can say. They are empirical formula, molecular formula and structural formula. You know acetic acid example, I just want to say acetic acid. Example, acetic acid. This is the common name. It is also called as ethanoic acid. This is also called as ethanoic acid. Dear children, what is ethanoic acid? Structure, इसका structure है CH3 COOH. This is the structural formula, and this is nothing but your structure. This is according to the chemical bonding. Okay, dear children, this structural formula indicates the exact nature of the arrangement of the atoms. Everything is there in this molecule, that is called as a structural formula. Okay, and you have the molecular formula, the exact number of each and every element. There are 2 carbons, there are 2 oxygens, there are 4 hydrogens. That is molecular formula. Exact number of every atom of each element is written in the symbolic form, that is called as an empirical formula, right? And the simplest ratio of this is called as a empirical formula. 2 to 4 can be written as COH2. So this is simplest ratio, this is the simplest ratio, and it is the exact number and it is going to be the arrangement of the atoms. That is what is called as a structural form. You understand the difference between structural formula, empirical formula and the molecular formula? Any doubt, you just tell me. Anisha, Danu, Chapala and all the students who are online right now, you just talk to me. It is a live interactive session. It is not a recorded session. It is not a radio session. And you want to have this kind of discussions, you need to pay a huge amount of money in your any coaching institute, and you have to travel a long distance and you can talk. And here on the YouTube platform, a chat box is given as a facility and you can talk to us and I can address your doubt and everything. And it is quite cheap and you can sit at your home with security and you can do it. Okay, simply please like our session. We want to do something best for our students. So please appreciate it by simply liking the session, sharing with your friends and subscribe to NEET Infinity Learn channel. Right, talking to how to find the empirical formula. Empirical formula can be calculated by taking the ratio of the atoms in the analysis. That's very important, bacho. That's very important. Okay, can we now talking about empirical formula of the compound is the simplest formula showing the relative number of atoms of different elements present in one molecule of the compound. So at least you need to have what is the exact definition of this. While the molecular formula represents the actual number, okay, actual number of atoms of different elements present in one molecule of the compound, right Anisha? And talking to the further details, so the molecular formula compound may be same as empirical formula. It doesn't mean that it is different. It could be same or different, right? And you can say the molecular formula can be calculated by multiplying with some number to empirical formula. So empirical formula into n, where n could be either 1, 2, 3 or so on. So an example, benzene, its molecular formula is C6H6. 6:6 is equal to 1:1. Its empirical formula is going to be CH. And acetylene or ethine, acetylene means it is ethine. C2H2, 2:2 is going to be 1:1. Similarly, acetic acid, we just learned C2H4O2 and it is going to be CH2O. Got it? Sir, empirical formula is molecular form is a simple ratio. Empirical formula is the simple form of the molecular formula. Okay, fine. Now, acetic acid, glucose you can see C6H12O6 and its empirical formula is 6:12:6, 1:2:1. So, it is going to be CH2O. Sometimes you just want to say H2SO4. Empirical formula is equal to molecular formula. You can say 2:1:4 na. You can't take the simple than this na. Simple is 1 is also included. That trang. Hope you understood, clear? And you want to take CH into 6 is going to be C6H6. CH into 2 is going to be C2H2. CH2O into 2 is equal to C2H4O2. And CH2O into 6 is equal to C6H12O6. Now, if you compare, empirical formula for benzene and acetylene is same. Empirical formula for acetic acid and glucose are same. But the molecular formula of the benzene and acetylene is different, and glucose and acetic acid is different. So, empirical formula can be same for different compounds, understand? And empirical formula and molecular formula can be same for a same compound. So, this is not so confusing, but you need to overview like this only. So, any doubt, my dear children, you can ask any doubt in the chat box. Just make it fast, make it fast. So, we will see how to calculate empirical formula and molecular formula. One important technique I just want to give you, N can be calculated by taking molecular weight by empirical formula weight. Molecular weight by empirical formula weight. So, its molecular weight you can see is going to be 180 and CH2O 12 plus hydrogen 2 plus 16 is going to be how much it is coming? 30. If you take like this, you are going to get 6. Understand? Clear? Fantastic, fantastic. Now, steps for writing the empirical formula. This is a notes, and this notes I just want to explain you, and you just take a screenshot of this, and at the end of the session in the Telegram channel you will be having a PDF format of this as well, so that you can download it and you can use it. Talking about divide the percentage of each element by atomic mass. So, this will give the relative number of moles of various elements present in the compound. I will do it. This point I just want to give you for your clarity. I want to do what? Each step I want to write in a stepwise manner. And divide the quotients that is obtained in the above step, and by the smallest possible number, so that you are going to get simple ratio of the moles. Once you get the simple ratio, that is going to be empirical formula. If that is a whole number, if it is not a whole number, you can divide, you can multiply. Multiply the figure so obtained by a suitable integer if necessary, in order to obtain a whole number retain. So, by only 3 steps I just want to give you, and finally write down the symbols of the various elements side by side and put above the numbers of the subscripts. So, that is going to be empirical formula of the compound. And steps for writing molecular formula. Any doubt? This is the steps, and I explained you, and I will use this, and I can give you the examples as well. Take a screenshot. Everybody, we will do some questions right now. Right now we will do some questions, bachcho. Make it fast. So, based on the empirical formula and molecular formula, even in the CBSC, you are going to get super important questions. Fine. Taken this, Anisha? Anisha, I'm here. I want to just leave the screen to take a screenshot. Everybody, yes. Now, steps for writing the molecular formula now. Now, once you got the empirical formula, calculate the empirical formula and find the empirical formula by adding the atomic masses of all atoms presenting the empirical formula of the compound. So, that is called empirical formula mass. And divide the molecular mass determined experimentally by some suitable method by the empirical formula mass, find the value of n. What I want to say, n can be calculated by molecular weight upon empirical formula weight. Got it? So, you can take this n value and multiply with, you can take this n value and multiply with empirical formula, so that you are going to get the molecular formula. So, doubts and free test series, you can download Infinity Learn NEET app in Android in the Play Store, and the link is given. You can click it so that you can have the free test, create your own test and ask your doubts as well. And by using this YouTube channel, we are providing the service. This is not a commercial YouTube channel, my dear children. And there is a question. Example, a substance on analysis gave the following percentage of composition. It is given at sodium is 43.4% beta. Solve along with me. I will solve this. And carbon is going to be 11.3%. Oxygen is going to be 45.3%. Calculate the empirical formula. How do we calculate the empirical formula? By simple, take a table like this. Like this table? Take a table like this. And elements, so a table याद रखना पहले. Okay, so element क्या element है? Sodium, you have carbon, you have oxygen. इसका symbol क्या? Sodium का Na, carbon का C and oxygen का O. Right beta? And their percentages are given here. 43.4% of sodium is given, right? And carbon is going to be 11.3, got it? And oxygen is going to be 45.3, yes? That's fine. So, this is the given data. So, you have to take the relative moles and simple mole ratio, right? Everybody. So, to take the number of moles, you take the percentage of that element divided by atomic number. So, what are the atomic number of sodium is going to be 23, carbon is going to be 12, oxygen is going to be 16, right? And take this percentage 43.4 divided by 23 is going to be the number of moles. Are you getting or not? Can we do that? Can we do that, Anisha? So, 43.4 divided by 23, it comes to be 1.88. And also 11.3 divided by 12, you're going to be 0.94. And 45.3 divided by 16 is going to be 2.83. So, this is the relative number of moles. So, the simplest ratio, take these numbers and divide them. इससे कम से कम नंबर कौन सा है 0.94. Divide them with the lowest possible number, so that 1.88 divided by 0.94 is going to be 2. 0.94 divided by 0.94 is going to be 1, and it is going to be 2.83 upon 0.94 is going to be 3. So, here I want to say sodium is to oxygen is to carbon are in the ratio of 1 is to 2 is to 1 is to 3. Therefore, I would write this as Na2CO3. So this is the empirical formula. Everybody, you understand? 0.94 will be taken. Wonderful. So this table yaad rakhna. You just memorize this table. Nothing, relative number of moles or simple mole ratio. Understand? Clear? Any doubt? Take a screenshot of this. Children, take a screenshot of this. Now, another, what is the simplest formula of the compound which has the following percentage composition? Carbon and hydrogen. Are simple na? It is going to be 80% is given. It is going to be 20% is carbon 12, hydrogen 1 is going to be here 20. Here it is going to be 80 by 12, 6 point something will come, right? What is the ratio here? 80 by 12. 6.66. So 6.66 upon 6.66 is equal to 1. So 20 upon 6.66 is going to be 3. So carbon is to hydrogen are in the ratio of 1:3. So empirical formula is going to be CH3. Are you getting or not? Clear? So I want some speed calculation from you. Yes, that's good. Datrang, are you solving along with me? We'll do one more. An organic compound on analysis gave the following data. Carbon 57.82, hydrogen 3.6 and rest is oxygen. And if the vapor density is 83, find its empirical and molecular formula. Will you do or you want me to do? Will you do or you want me to do? Waiting for your response. You want to do? Okay, I'll wait here. And this empirical formula, those students who are trying themselves, take a minute and do it. And I'll be waiting here. And just let me recap what is empirical formula and molecular formula. Empirical formula is the simplest ratio of the every element present in the molecule is called as an empirical formula. And the molecular formula represents the exact number of every element present in that molecule. Compound is called as molecular formula. Okay, so first to calculate the molecular formula, we need an empirical formula. Sometimes empirical formula, molecular formula, दोनों भी बराबर हो सकते हैं. They can be same. To find the empirical formula, you can calculate the empirical formula from the percentage of the elements that are available obtained by the experiment methods like Liebig method. Liebig method is for carbon and hydrogen. You can go for the sulfur, chlorine, bromine and hydrogen and phosphorus by Carius method, nitrogen Dumas method or Zeldal method, and the oxygen is going to be the subtraction method, right? So once you calculate these percentage of the elements given in the compound, you can calculate the empirical formula by taking the simplest ratios. First, for that the percentage is divided by the atomic mass to get the relative moles, and that relative moles is divided with the least possible number to get the simple mole ratio, and this simple mole ratio can give you the empirical formula. Simple whole number values you have to consider, and this particular compound is going to have the empirical formula and the molecular formula. So your 2 minutes is over. Can we start doing? Anisha, make it fast. If you are done, you just tell me. I am going to solve it for you guys. Over? Yeah, it is going to be C4H3O2. Is that? Okay, fine. For that, what we do, take the elements. What are the elements here? I got the carbon, I got the hydrogen, I got the rest is oxygen, right? Carefully see, carbon percentage is 3.6, carbon, hydrogen, oxygen, right? And the carbon percentage is 57.82 and hydrogen is 3.6 and 57.82 100 minus 57.82 plus 3.6 and is coming to be 38.58. This value is not given, it is set at rest. It is set at rest. Understand? Clear? 4.04 molecular formula, 4.8 in. Okay, atomic weights of carbon is 12 and hydrogen is 1 and oxygen is 16. And take the percentages and it is going to 57.82 divided by 12 is going to be 4.80. 4.8 in carbon. 57.82 na? Okay, 4.8 in carbon, exactly. Anisha, and 3.6 divided by 1 is equal to 3.6, 3.5, where do you get 3.5? 3.6 na? Yeah, Anisha, it is going to be 38.58 upon 16 is going to 2.40. Now, this is the relative number of moles and take the every number and divide with the simplest, lowest possible number is, this is the lowest possible number. So that 4.8 upon 2.4 is equal to 2 and 3.6 into 2.3 is equal to 1.5 and here it is going to be 2.4 upon 2.4 is going to be 2. It is going to be 1. It is going to be 1, right? Now, I want to take this into the simple whole number ratio. So, it divide with 2, it is going to be 3, it is going to be 2, it is going to be 4 and it is going to be 2, it is going to be 2. So, empirical formula is going to be C4 H3O2. Got it? C4H3O2. Are you getting or not? Exactly, Anisha. Now, let us go ahead. And molecular formula, empirical formula into N. Empirical formula is going to be C4H3O2 into N. And how do I get the N value? N value is equal to molecular weight into empirical weight. So, vapor density is given 83. So, molecular weight is equal to 2 into vapor density, which indicates 2 into 83 is equal to 166. Is going to be 166. And empirical formula weight is going to be C4H3O2. How much it is coming? Anisha, how much it is coming? Empirical formula weight, it is coming exactly 83. 83. On putting 83 over here, you are going to get a 2. So, let us make it a 2. Okay, let us make it a 2. and it is going to be C8 H6O4. So this is the answer for this question. NEET examination questions will be like this only. Take this calculation, require at least a little patience to solve this. Any doubt, bachcho? Any doubt? You can ask us if you have any doubt. If you have any doubt, you can discuss with us. Okay, now 2.746 gram of a compound gave on analysis 1.94 gram of silver, 0.268 gram of sulfur and 0.538 gram of oxygen. Find the empirical formula of the compound. Atomic masses are given. Everybody, I want you to do, take a minute, use the same method, and I want to see the confidence levels in the students. So these sessions are given for the students to raise the confidence level in you. So पढ़ाई कैसे करना, हार्ड वर्क कैसे करना, एग्जाम कैसे निकालना. So try to crack the question. Okay, so cracking the question can lead to you a lot of confidence. Okay, if you are solving a question and you struck up somewhere and you lost it, not with that question, and you lost your confidence also. So when you do this, and you will get the confidence, you will get the question, you will get the answer, and you will get the confidence. So dear students, mind it, NEET is all about the NCERT. NCERT is everything for your NEET. Let it be physical chemistry, organic chemistry, inorganic chemistry, and NEET NCERT. So the pattern of the question changes, but maximum 1 or 2 concepts, and it is around the NCERT concept only. Okay, focus on, I want you to do this. Make it so that we can discuss the stoichiometric calculations. Over, make it fast. It is, Anisha, here we have silver and sulfur and oxygen. So these are the 3 elements that are being given, right? And symbol of the elements Ag, S and O. Okay, and percentages, silver has a percentage 70.65, 1.9 gram of silver. How do you get this? 70.65. Carius method, understand? Exactly, Anisha. And from there you can get the sulfur percentage also 9.75. Carius method. And oxygen, you can directly take it subtraction from there, right? And their atomic weights is 108, it is given. And here sulfur is given 32 and oxygen is given 16. Okay. And how do you calculate the relative number of moles? 70.65 by 108, it is going to be 0.654. Okay, 1.94. Okay, you did that method, huh? You can do that, also. And 9.75 by 32, 0.305, and 19.6 by 16, 1.22. and take these values and कम से कम नंबर कौन सा का है 0.305 का. So 0.654 and 0.305 is 2. 0.305, 0.3051, 19.6 by 16, and it is 1.22, 1.22 upon 0.303 is going to be 4. So 2:1:4, it is going to be Ag2SO for silver sulfate. Silver sulfate. Anisha, doing so nice. Okay, you are attending my classes on a regular basis. Last 2024 also, very good number of students were there, and they are attending my classes on a regular basis on the YouTube platform, and they did well. They did well in the NEET examination, right? Any doubt? Percentage is not given. That's the reason why weight is given now. Anisha, weight is given now. From that weight of the silver, you can calculate. Okay. Next. Stoichiometry. Let us talk about the stoichiometry. Stoichiometry is a study of chemical reactions and calculation related to it. Okay. So this gives a very good impact on these calculations, mole calculations in the chemical reactions. For that you need a basic chemical balanced reaction. A study of chemical reaction, first of all, we always balance it. Balancing involves equating the number of atoms in the reactant side and the product side. Anisha, you can calculate that also. Definitely you can calculate. You are true. Okay. And unbalanced reaction, sulfur dioxide plus oxygen gives us sulfur trioxide. This is unbalanced reaction. To make it balanced, use heat and trial method and use some numbers to balance the number, so that it is going to be 2SO2 plus O2 gives us 2SO3. Okay. So how much? So law of mass and conservation. Law of mass conservation, you have to use it. That is the main course of stoichiometry. And we have, in order to solve the problem based on chemical calculations, of these steps are required to helpful. First of all, again notes. So in the class you are getting a notes as well as concept as well as and questions. Okay. So write the balanced equation. Once the question is given, you have to follow these steps. As a learner, I am taking you as you know nothing, and I am discussing the things with you, and you follow this. Write the balanced equation. Once the balanced equation is given, write the atomic mass and molecular mass moles of the volumes of species involved in the calculations below the equation, right? And calculate the result by applying unitary method. That is a method. Okay, if 10 moles are given, okay, for 5 moles how much? That is called unitary method. You can do it. Okay. And here, interpretation of balanced chemical equation. So what you understand once the balanced chemical equation, you got it. So Chaitanya Academy Atre NEET program is there. Sri Chaitanya Academy Atre NEET program. You click it and you learn it and you can do the best. Okay, once you will get the balance, once you got a balanced chemical equation, then we can interpret a chemical equation by various ways. Let us say mass analysis, mass volume analysis, and volume analysis, and mole analysis also there. So let us take a potassium chlorate is on heating gives rise potassium chloride and oxygen. Okay, so this is the equation. KClO3, potassium chlorate. Now this is all about the mass analysis. I wanted to say 2 moles of this, look at this, carefully look at this. 2 moles of this can react to gives rise 2 moles of this product, and 3 moles of this product. You understand? You know the number of moles is equal to weight of the substance by molecular weight. Okay. So I mean to say 2 into weight of KClO3 upon molecular weight of KClO3. You can say 2 into weight of KCl upon molecular weight of KCl and 3 into weight of oxygen upon molecular weight of oxygen. So like that you can write it. Now let us take the relation between these two. Let us take the relation between these two. So that is 2 into weight of KClO3 upon molecular weight of KClO3 is going to be 122.5, right? And is equal to 2 into weight of KCl and molecular weight of KCl is going to be 78.5. Okay? And if something is given, you can calculate the mass of the compound that can be formed. And here you can say weight of KClO3 upon 122.5, weight of KCl upon 74.5. This is one interpretation, exactly. Similarly, 2 into weight of KClO3 upon 122.5 is equal to 3 into weight of oxygen and 32. Now, if this much amount of KClO3 is heated, how much amount of KCl can be formed? That is one method. Or otherwise, you can calculate unitary method as well. Are you getting or not? Clear? My dear children, any doubt? My dear children, any doubt? So, a question is given. Will you solve or you want me to solve? 367.5 gram of KClO3 is heated. How many grams of KCl is going to be produced? You tell me quickly. Quickly. Yeah, that is going to be weight of KClO3 upon 122.5 is equal to weight of KCl and 74.5. Weight of KClO3 367.5, 122.5. Weight of KCl upon 74.5. Weight of KCl is going to be, tell me in the grams. Quickly tell me in the grams. Anisha, waiting for your value. Three mole, 367.5 divided by 122.5 into 3 into 74.5, 223.5, right? Exactly. And similarly, we will be talking about consider the reaction, mass volume. You can talk about this 2 into, that is 2 mole, this is 2 mole, and this is going to be 3 mole. Right? Exactly, Datrang, what you said is correct. What you said is correct. I really appreciate students are solving along with me in the class. This is a good sign for development. Okay, dear children, 2 mole and 3 mole, and it is all about the mass and volume. So volume relation is strictly for the gases, not for the solids. Okay, so talking about the weight, 2 into weight of KClO3 upon 122.5 is equal to 3 into volume of oxygen upon 22.4. That's it. So in liters, you have to take this volume and oxygen in liters. Understand? Clear? Very important, right? So what volume of oxygen at NTP, STP same hoga beta, okay, can be produced when 6.125 gram of potassium chlorate is heated according to the equation. 2 KClO3 gives rise to 2 KCl plus 3 O2. What could be the answer for this? What could be the answer for this? That is 2 into weight of KClO3 upon molecular mass 122.5 is equal to 3 into volume of oxygen upon 22.4. It comes to be 2 into 6.125 upon 122.5, 3 into volume of oxygen and 22.4. You tell me the volume of oxygen that can be obtained in liters. In liters. Now we'll go into 1.71. Karim, so where did you go so far? I am waiting for you. Karim, I am waiting for you. Datrang, got it? Anisha? Now let's discuss about the limiting reagent. That's very, very important. Ready to talk about the limiting reagent? Yeah, that is going to be 1.71 liters. Which early consumed in the reaction decide the formation of the product. Volume relation. Okay, we'll discuss that also. What mass of calcium oxide will be formed on heating with 5 kg of calcium carbonate? No. That wrong. If nothing is mentioned, you take 22.4, and if it is specifically mentioned 22.6 in the question, you use that value. Okay, what you said is correct. It is not 22.7 beta, 22.6. Fine. So what exactly happened? Calcium carbonate on heating gives rise calcium oxide plus carbon dioxide, right? So one molecule of calcium oxide gives rise one molecule of calcium carbonate gives rise one molecule of calcium oxide and one molecule of carbon dioxide, right? And 1 mole of calcium carbonate, that is called limestone, on heating gives rise calcium oxide, quicklime, and carbon dioxide. Okay, but NTP should be 22.6 or 22.7. Okay, different books, different values are given. Unless it is mentioned, you don't use that. By default, you have to use 22.4 only. Karim, exactly, you said correct. So 100 grams can give you 100 grams of limestone can give you 56 grams of calcium oxide and 44 grams of carbon dioxide. Okay. So 1000 grams, 100 grams calcium carbonate gives 56 grams of calcium oxide beta. If it is a 5000 grams, 5 kg means 1 kg is equal to 1000 grams. Got it? Anisha. So it is going to give 56 upon 100 into 5000 grams of calcium oxide, and it is going to be 2800 grams or 2.8 kg. My answer is going to be 2.8 kg. Anisha and Karim, where do you miss the calculation? You miss the calculation, huh? Calculations are so costly, right? Calculations are so costly. Now, limiting reagent. Karim, I am coming to that. Limiting reagent is the ice-breaking topic. Limiting reagent is the ice-breaking topic in the entire stoichiometry. Bachcho. So, the reactant that gets exhausted and limits the reaction is called limiting reagent. Arnav Hazarika, hi. During a reaction, so one of the reactant is going to be completely consumed and decide how much a product is going to be formed. That is called as a limiting reagent. Okay. So similarly, there are some reactants which are left. If something is consumed means the reaction is going to be stopped, and the reactant which is not consumed completely is called excess reagent. If one is the limiting reagent, another is going to be excess reagent, and useful when number of reactants are more than 2. So this is the trick, my dear children. This is the best method to identify limiting reagent is simply divide VTP, good afternoon. Simply divide the given number of moles. Simply divide the given number of moles by stoichiometric coefficient. What is stoichiometric coefficient? You use some number to balance the reaction. That is called stoichiometric coefficient. Okay. So an example, 3A plus 6B gives us 3C plus 5D. So that is the example, hypothetical example. Okay. So given moles are, given moles are 9 moles are given, he is asked to react with 27 moles of B. So what I do, simply take this to find the limiting reagent, 9 divided by 3 and 27 divided by 6. 9 divided by 3 is going to be 3. Okay. And it is going to be 6 point something, 4 point something, right? Now, this is the least ratio, it is called as a limiting reagent. So, this is going to be limiting reagent. Understand? Clear? A is the limiting reagent. Got the trick? Clear, beta? It could be anything. Take the number of moles and divide with the respective stoichiometric coefficient. Is called a limiting reagent. 4 moles of magnesium carbonate is treated with percentage yield. Let us talk about the percentage yield. Let's start from a small but important concept. It's very important. The percentage yield. I'll tell you the percentage yield. I written an examination. I am expecting to get 100 out of 100. Question paper is for 100. I written the paper. I am expected to get 100 out of 100. But I got only 90. So there is something lost because my handwriting is not clear. There is some calculation error. Understand? Karim, Anisha, Hajarika. Okay. So, in the experiment also, I want to prepare some oxygen. Okay. So, simply potassium chlorate is heated and getting oxygen. So, I want to get this 100 ml of oxygen in the experiment theoretically, but I am not getting 100. Why? Experimental issues, purity of the compound, and many things. Not all the reactions produce the amount of the product which is expected. Exactly, Karim. Which is expected from stoichiometric calculations. Why so? This happens due to the process involved in the practical problems, dear. This is happen practical problems. You have to adjust your mind with that. So, percentage yield can be calculated. Actual yield by theoretical yield into 100. Karim did well. Karim did well. Okay. So, this is a super important formula. And also you can calculate, this is not about the percentage yield, this is about the percentage of the purity. Calculate the mass of quicklime that is obtained when 1 kg of 90% pure limestone is strongly heated. Who is going to do this? Who is going to do this, my dear children? I want you to do this. Is that question is available, my dear children? Exactly. Karim, Arnav, Hazarika, Anisha, VTP, mass of pure by mass of impure into 100. Yes, exactly, beta. Now you can see limestone, it is heated, right? CaCO3 on heating gives rise CaO plus CO2. So this is called as limestone and this is called as quicklime. Okay, calculate mass of calcium oxide when mass of limestone is given CaCO3. You have strongly heated 90%, 1 kg of 90%, 1 kg means 1000 grams. So the percentage purity, weight of pure upon weight of impure into 100. So 90% weight of pure इसका 1000 होगा into 100. So weight of pure is going to be 900 grams. Okay. Now it is given if 100 grams of pure होगा तो ये 56 gram होगा if it is a pure. If it is 1 gram होगा तो 56 by 100 gram होगा. Okay, हमारा पास 90 ग्राम था. So 900 grams होगा तो कितना मिलेगा? That is equal to 56 upon 100 into 900. So how much it is coming? You only complete the calculation and tell me. You only complete the calculation and tell me. Make it fast. How much, Anisha? How much, Anisha? Got it? Clear? That's good. Dear children, today we discussed about so many things, percentage calculations by Liebig method, by Dumas method, Zeldal method, Carius method. From there we calculated empirical formula, molecular formula. Then eventually we enter into the stoichiometry, then weight and weight volume calculations. Yes, it is. Datrang, yes, it is. Now, limiting reagent we discussed, then percentage yield, percentage purity is also calculated. In the future classes, we are going to start with atomic structure where quantum theory, Max Planck quantum theory and photoelectric effect we discuss it. And we will be discussing so many things based on that. And like you are enjoying the class, Anisha, Karim, Datrang, Hope these sessions are helpful to you. Helping? Yes. Please like this session and share with your friends and subscribe to NEET Infinity Land channel and stay our journey for this next NEET examination with a colorful. Okay. Thank you very much and signing off, Suresh, Faculty of Chemistry from Infinity Land. Bye bye.